All right, so what the first thing we'll do is to go through the homework assignment where you have to trace through, I think, 3 individual test cases of the binary search algorithm. So that's what we'll do first, and then we'll move on back to Scratch, because I promised you guys that we'll go ahead and finish up the hand-person game, and so that's what we'll do next. Guys.
Sorry.
All right. Oh, you made it out of Scratch?
Yeah.
Cool. How do you guys like Scratch?
It's slow.
If it's slow, yeah, but it also gives you a lot of things. It's easy to do certain things
True.
that would otherwise be kind of difficult.
Very.
Yeah. It's time to upgrade that processor.
Yeah. That's my fault.
You need an i7 then. Just to run Scratch.
Man, what are you doing? Don't name
All right, so we'll do the homework assignment first. This is our binary search homework assignment. And hopefully people did not run into too much trouble. All right, so let's go ahead and start with sheet number 3. And I'll try to magnify as much as I can so we can all see better. There we go. Starting with line 1. Line 1 is pretty simple. B gets a value of 0, so we put a 0 here. Line 2 is initializing E. E gets bar A bar minus 1. Bar A bar is the number of elements in the array. In this case, we have 5 elements. So bar A bar is 5. 5 minus 1 is 4. So E has an initial value of 4. We don't trace line 3. If you put line 3 down, it's okay. I'm not going to take any points off. But I'll just go ahead and go to line 4. Line 4 has to calculate B plus E divided by 2, and then take the floor of that particular value. B is 0. E is 4, so 0 plus 4 is 4. 4 divided by 2 is 2. The floor of 2 is just 2. So M gets a value of 2 in this case. So nothing really, exciting here. But starting on line 5, we get something a little bit more exciting because we have a condition to evaluate. A bracket M is less than K is either true or false. In this case, M has a value of 2. So A bracket M is A bracket 2. A bracket 2 is column J. It has a value of 6. So we are now comparing 6 to K, which has a value of 1. 6 is less than 1 is false. And this is a multi-branch conditional statement, so we have to go to line 7. Line 7 has another condition to evaluate, which is the flip side of the earlier one. A bracket M has a value of 6. 6 is greater than 1 is true. So now we have to go to line 8. Line 8 is going to change the value of E, so it becomes M minus 1. M has a value of 2 at this point. 2 minus 1 is 1. And then we get out of the conditional statement, we go to line 10. Line 10 has the condition to evaluate. A bracket M equals K is false because 6 does not equal to 1. But we have a second chance to make it false. To make it true, which is B is greater than E. B is greater than E. B has a value of 0. E has a value of 1. B is greater than E is also false. False or false is false. So this entire thing is false, which means our exit condition is false overall speaking. Which means where do we go next? We go back to line 4. We go back to line 4. We have to recalculate M. 0 plus 1 is 1. 1 divided by 2 is 0.5. The floor of 0.5 is 0. So M gets a value of 0 this time. Then we go to line 5. We evaluate the condition of A bracket M is less than K. M has a value of 0 this time. A bracket 0 has a value of 2. 2 is less than 1 is false. Okay. So that means we go to line 7. A bracket M has a value of 2. K has a value of 1. 2 is greater than 1 is true. Then we go to line 8. What do we change what do we change E to this time? Is M minus 1. M is 0. 0 minus 1 is negative 1. That's right. Then we go to line 10. Line 10 is going to evaluate A bracket M equals K. What is A bracket M equals K? It's false, okay? Wait a second here. Is M still a valid index into the array? Yes, it is. M. I changed E, not M. So it's a trick question, okay? I'm just making sure that we pay attention to M before we do the indexing. What about B? B has a value of 0. E has a value of negative 1. 0 is greater than negative 1 is true. So the entire disjunction is true. Now it's time to get out to line 11. Line 11 is an assignment statement. The right-hand side is A bracket M equals K. A bracket M is A bracket 0, has a value of 2. K has a value of 1. 2 equals 1 is false. Okay, so found has a value of false. And we're done. Post. If I see this, that's okay. It just means it's running out of space to display false. Yes?
But if it's going to be true, we write found or true?
True.
Okay.
Because the right-hand side is a Boolean expression. It evaluates to either true or false.
Okay.
Question? Say again? That's fine. That's good. Yep. All right. Any questions about this particular trace? Any part of it being a little bit tricky? No? Okay. Let's go to the next one. All right, so we start pretty much with the same thing. Line 1 initializes B to 0. Line 2 initializes E to 4. And then we get to line 4. M gets a value of 2. This part is the same as last time, so nothing really exciting here. Now starting on line 5 is different, because this time A bracket M, which has a value of 6, is less than K, which has a value of 11, is true to begin with. So this trace is going to be a little bit shorter, not by much, just a little bit, because now we go to line 6. Line 6 is changing B, so that this time it becomes 3, because it's M plus 1. And then after line 6, we get out of the conditional statement. We get to line 10. And then we evaluate A bracket M equals K. Is that true or false? It's false, okay, but we have a second chance to make it true. What about B is greater than E? Is that true or false? It is also false, so the whole thing is false. If the condition of it until is false, we have to continue with the loop. So that means we go back to line 4. 3 plus 4 is 7. 7 divided by 2 is 3.5. The floor of 3.5 is 3. Okay, then we go to line 5. A bracket M, which is A bracket 3 in this case, has a value of 8. 8 is less than 11, or K is true. Then we go to line 6. Line 6 is going to give a new value to B. B gets M plus 1. M has a value of 3 now, so it has 4 after this iteration. We go to line 10 after that. A bracket M is A bracket 3. It has a value of 8. 8 equals K, which is 11, is false. Any questions? No. Okay. How about B is greater than E? It's false, because they are the same. Okay, so when they are the same, we do not get out of the loop yet. We go back to line 4 again. This time, what should M be? It's easy. It should be 4, right? Because B is 4, E is 4, 4 plus 4 is 8, 8 divided by 2 is 4, and the floor of 4 is 4. Okay. That sounds like the phone number of some lawyer. Yeah, 444-4444. You know, I think that ad worked, okay?
Yeah.
You know, because we can all remember the phone number. I don't know how many pranks it gets.
All of them. All of them.
Okay, so A bracket M is now A bracket 4. It has a value of 10. 10 is less than K, which has a value of 11, is true. We go to line 6, and this time how do we change B? B becomes 5 because it's M plus 1. And then we go to line 10. A bracket M equals K is still false, but B is greater than E is true, so the whole expression is true. We go to line 11, and found is going to be false. And that's the end of this trace. Any questions about this one? No questions? Any questions? No questions? Okay, let's move on. This is the only one that will give you an answer of yes, we found it. You guys have any questions? Any particular questions? Okay, because I can see that you're working on the homework stuff. I just wanted to see that, make sure that if you have any questions, I can answer them next one. Wait for the next one. Okay. All right. So same thing here. Line 1 initializes B to 0. Line 2 initializes D to 4. Line 4 is going to give M. Oops. Line 4 gives M an initial value of 2. And then here we have line 5. Now this one is a little bit tricky because we should be able to find the value 10 in this case. So we want to find out, how we are changing the values of B and E so that we can eventually find M. Okay. If you guys have any questions, go ahead and ask me instead, because otherwise, the other students are trying to listen to what I'm saying, and it will just be kind of distracting to the other students. Question?
No, just waiting.
Okay, all right. So now we have up to line 5. A bracket M is A bracket 2 is less than K. Is that true or false? A bracket M is 6 and K is 10. 6 is less than 10 is true. We go to line 6. Line 6 is going to change the value of B to become M plus 1. M is 2, 2 plus 1 is 3. Then we go to line 10. A bracket M equals K is false. B is greater than E is also false, so the entire condition is false. We go back to line 2. How should we change M this time? 3. 3 plus 4 is 7. 7 divided by 2 is 3.5. The floor of 3.5 is 3. So M has a value of 3 this time. We go back to line 5. A bracket M is less than K is M has a value of 3. A bracket M is A bracket 3, which has a value of 8. 8 is less than 10 is true. We go to line 6. And B gets bumped up by 1 this time, compared to M, so it becomes 4. And then we go back to line 10. A bracket M equals K is false. B is greater than E is also false, so the entire expression is false. We go back to line 4. This time M has a value of 4. We go to line 5. A bracket M is less than K is false, because this time they are the same. 10 is 10. 10 is not less than 10. We go to line 7. 10 is greater than 10 is also false. So there's nothing to do inside the conditional statement. We go to line 10. Line 10 is says A bracket M equals K. Is that true?
Yes.
So we stop right there. We do not evaluate the entire disjunction because we use this short-circuited evaluation. Okay? You always have to remember the short-circuited evaluation because it is important. Yep.
So, is it not okay if we wrote out that whole thing and then put true? Like that is true?
I will let you guys slip this time, because I did not specifically say, make sure that you indicate it is using short circuit evaluation. But in an actual program, when you take a programming class, it is important that you remember that it is using the short circuit evaluation method so that the second half is actually not evaluated in this case. Okay.
I was actually going to ask the same thing.
All right. All right, so if that condition is true, we get out of the loop, we go to line 11, and quite obviously this time, found is going to have a value of true because we just evaluated the same expression. All right, and post. There we go. Any questions about the trace? No questions? It's a little bit longer than last time, in terms of the length of the trace, but I think in terms of complexity, it's not too bad. Any questions? No questions? All right. If there are no questions, we're going to go back to Scratch, and we'll take a look at the Hangman game. How many people have put some thoughts into it? Okay. So how far did you guys get?
Pretty much done.
You're done?
All right.
Okay. There's no way, I could not find a way to connect to any external dictionary. Did you find any way to do it? No?
So I had to make my own.
You didn't try to hack it?
I did not.
Add a new feature, connect to external world.
That would be nice.
That would be nice, yep. All right. Okay, so let's go back to hangman or hang person, and we want to do it by hand first, just to figure out what we need to do to make the game go. Okay, and I'll probably use a notepad here. I'll use my mouse pad. So this way everything is logged. I'm not going to write anything on the whiteboard unless I really have to. Roll sheet, thank you. This one. Yep. All right. Yep, go ahead.
You mentioned after we got the test back, you were going to have us do an extra credit assignment. Is this going to be what it is, or did you?
I'm going to do this one myself,
Okay.
so I can show you, all the features of Scratch and how to combine the features.
Okay.
And then I'll give you guys, a different assignment. I think this one, even though, some people can do it, it's actually not that simple as an extra credit assignment. So I'll find something else for you guys to do. All right. Okay, so in this case, I have to make some assumptions because we want to mentally go through the process and find out, okay, how do we make this program work step by step? Okay, that's basically the question. So we want to go through like example 1 and try to figure out how to make this work. So I want to use the same example as last time, so the word to guess, okay, the word is feet, okay? So we want to find out what we have to do in order to keep track of the letters that have been guessed. And also, if someone is guessing the correct letter, what do we have to do? Okay. Do you remember from last time what we have to track? Okay. I think we wrote down something last time, about what we need to track. So I'll just write down here. We need to track the following. Letters already used, right? Now, in a real hangman game, if someone forgets, which letter has been guessed and use the same letter again, does that person get a second chance? And do you just tell the other person and say, "Oh, you tried A already. Try something else"? That's usually how it goes, right? No, you just draw another stroke. Okay. Now, if you don't want to keep track of the letters already used, that's one fewer things to keep track of. Okay, but let's just say that we want to be nice. Okay, we want to be nice, and basically Scratch will say, "Oh, but you used this letter already. Use something else." Okay, so we'll keep track of that. We'll keep track of the actual word. We'll have to keep track of the partial word. Okay, so this is the result of the guesses. Okay. What else do we have to keep track of? The state of the hanged person. Okay. I'm pretty sure hang person is still politically incorrect, but it's fine in this class. It's not. Yeah. All right. Okay. So when we look at these things, how can we figure out whether a letter has been used or not? How do we keep track of something like that? What do you think? There are two ways to do it. One is you can have an array of 26 things, and then each one represents each letter, then you can figure out which one has been used already. The second one you can use is to use what we call a string. In other words, you just keep appending a letter to the end of a word, and that word is basically all the letters that have been used already. Okay. We might want to try that first. Okay. So we want to just kind of test that mechanism. Now this part is important because we don't want to write the entire program in one shot. Okay, from cover to cover or from the first line to the last line. I cannot write a program like this in one single shot. I have to break it up into smaller components and test each component to make sure that, okay, this part works, and then move on to the next component. Okay? So what I'll do is I'm going to do this. Okay? Just write the component to keep track of letters already used. Okay. And I'll just write down here, if a letter has been used, ask the user to input another letter. At the end of each guess, add the new letter to the list of letters already used. So these are the three things that I want to do. Okay? So let's go ahead and see how we can do this in Scratch. I really like Scratch, in a way because it's very easy to build up a program step by step. There's not a whole lot of copying and pasting, adjusting the indentation. You just kind of drag and drop the blocks. So in a way, it's really nice like that. All right, so we go to the control block here, and you can either use, clicking or a green flag. I'll just use a green flag here. I don't even have a hangman costumes designed yet, but that's okay. We can always deal with that later. It's not time yet to deal with that. So I'll just say that start the script when the green flag is clicked. And I want this to be simple first. Okay, I just want to ask a question. Okay. Give me one letter. And I use a variable here, make a new variable, and I'll just make this letters used, or used letters if you will, used letters, for this sprite only, okay, just like that. And then what do we need to do? How about I make this program really simple first, and it's not going to be very smart. It's a forever loop. It just keeps doing the same thing over and over again. I'm just kind of worrying about the part of adding something to the list. So I just want to make sure that part works first. Are we doing okay so far with what I intend to do? So if I wanted to turn this into an infinite loop, I will go to the control part here, go to forever, stick it here, add, give me one letter and wait. And I go to variable. Every time I want to change a variable, I have to use either set or change. Change doesn't really work in this case because change is only going to work with numbers, because you're either increasing the number by a certain amount or you're decreasing a number by a certain amount. In this case, we're trying to append something to the end of an array. We're making the array bigger and bigger. So what we need to do is to use set in this case, and the only variable we have is used letters, so that would be fine. But what we want to do is to go to operators and then pick out join here. So what we want to join will be two things. One thing is used letters itself, and then the other thing is the answer to the question that I asked earlier, like that. All right, do we have any questions at this point? This is it. This is my first revision of the Hangman program. It doesn't do much. It doesn't even check whether a letter has been used already. All it does is to say, oh, just give me a letter. I'll just add it to the end of the list of used letters. That's all it does. Okay? But I want to work on this program step by step. So this is very easy to verify. I can now go to variables and make sure used letters is displayed, and it is displayed here. Okay. And we'll go ahead and run the program. So it says it'll give me a letter. I'll just start with A, E, I, O, U, and so on. It seemed to work okay, except for one thing. What's that 0 at the beginning? What do you think? It's the initial value, exactly. So what we use, as a question mark to indicate that a particular variable has an unknown value, in Scratch, they all start with a value of 0. But that's not going to work here, okay? Well, I guess it doesn't really conflict with anything because 0 is never really a usable letter in Hangman. But we can change it. We can make it a little bit nicer. So what we can do is to use an initialization here and just say used letters to nothing. I just press the delete key after selecting the 0. So now it becomes an empty array, if you will, or we call it an empty string. Okay, so now there's nothing there. We'll go ahead and run the program again, make sure that this time it works the way it's supposed to. See how it is nothing here? So I can type in the same thing again, A, E, I, O, U, and it works, okay? Now it's keeping track of all the letters that I'm typing in. But it doesn't check whether it is already there. Sorry? Yes. Mm-hmm. In fact, it doesn't check whether it's a single letter or not. Very good. That's right. Yep. It's input validation, right? We'll deal with that later. We can build a program step by step. Okay. Are there any questions at this point about the program? Okay, so what he just mentioned was, we did not do any type of validation. In other words, the user can type in anything at this point. The user can type in the asterisk symbol, okay, and then press the enter key. It accepts that as an input. The user can input, this is a long sentence, and it takes that as an input too. Well, in the real Hangman game, we should not be taking these as valid inputs, right? What do we do to double check and make sure that the input is correct? What are the criteria of the input? Okay, we want to check the length because we want a single letter, and then what do we do? Let's say I know it's a single thing. What else do we need to do?
Restricted to the 26 characters.
Restricted to the 26 characters. All right, very good. So let's go ahead and enhance the program a little bit and make sure that we can, validate the input here. Okay, where do you think I should put the validation? Okay, somewhere between the ask and the set, maybe. Does that make any sense? Because the asking part, still has to be done, so it gives me at least a prompt. But I cannot use the set operation until I know the answer is actually validated. So that would be a good place to do it. Okay. The validation process itself. Do you think it's a loop or do you think it's a conditional statement? In other words, is it a one-shot thing, or is it possible that I have to do something over and over again? Which one is it? Possibly over and over again, because somebody can give me the wrong answer all the time, so I have to re-prompt all the time. Okay, so let's go ahead and look at the control here, and you can tell me which control we should use. since we already know it has to be a loop or something that is repetitive in nature, what about forever? Doesn't sound right? How about repeating 10 times, or give it a certain number of times? It doesn't. Repeat until, okay, that works, okay, because we are waiting for a condition to become true, okay. Now, but when we use this one, we have to be careful, okay, because when you look at this, it seems to suggest it is just a repeat until, which is a post-checking loop in pseudocode. This is actually a pre-checking type of loop, because the repeat until is before the body of the loop itself, so it's actually checking the condition before it performs the first iteration. So we have to be careful, but that's the only choice we have. That's the only real choice here. So I'll just go ahead and break this part up, put this back inside here, and then the ask has to go in here because I want to prompt every single time, just so that the end user knows, one letter, right? Not more than one. When we do a validation, what should we put into the hexagon? In other words, what would be the condition I need to specify here? You guys already said it in a way, but what should we put here? It's going to be a little bit long, okay? So we'll go ahead and work on this, one at a time, okay? We don't want to work on this, too quickly. So first of all, let's make sure it is just one letter, okay? One thing at a time. So what we'll do is we'll go to operators, and then we have a comparison because we want to compare the length to 1, and then we pick out length here on one side, but we don't care about the word world. We care about the answer to the question that we just asked. So we want the length of the answer to be exactly 1, just like that. But we have a problem because this is a pre-checking loop, which means it's going to try to utilize properties of answer before even asking. Okay? The only way to fix this one, or the only easy way to fix this one, is to prompt before the loop. Okay, so in other words, I can duplicate this block here and put it before this. There's another way to fix it. The other way to fix it is to use a variable to indicate whether this is the first time we get into the loop or not. Okay, sometimes one approach is better, sometimes the other approach is better. In this particular case, let's just duplicate this block here and put it before this, and then we put the entire thing inside the loop and make it before the set instruction. Do you think this will make sure that we are only inputting one thing at a time? Well, let's give it a try. Okay. So I will intentionally give it something that is invalid. Okay, I'm not going to type anything and just click the check mark here, and it doesn't let me pass. Okay. I will type in, this is a long sentence, and then it doesn't let me pass. If I try to type in A all by itself, it let me pass and it adds it to the list. If I type A, B, C, it doesn't let me pass. On the other hand, I can still have mistakes because I can use the asterisk symbol and it will still let me pass. So the program is working a little bit. It does have some validation, but it's not complete yet. Are we doing okay so far with this program? We good? Okay. So the next thing we want to do is to say, well, this is good. We're doing some validation, but we also want to make sure that the character, the letter, or the input is a valid letter. It's not a punctuation. It's not a digit. It has to be a letter. How can we check that? Well, what type of operator do you think would be helpful in this case? It has to be from A to Z, which means anything outside of this range is not good, right? So what operator should we use? comparison, right? Greater than, less than, that sort of comparator. What about equal to? You can use equal to, but it will be extremely tedious to do that. Because when you use equal to, then you have to say it as, it's okay when the answer equals A, or answer equals B, or answer equals C, or answer equals D, or answer equals E, and so on. So you end up with 25 disjunctions and 26 comparisons. Yep.
Or you could just put all the letters into a list instead of using a variable. Just use a list.
Okay.
And if then you can use equals.
It doesn't. There's no way to compare to an entire list. If you go through the operator, that's all that you can do. So what you need to do is this. Okay. So here's the answer. Okay. This is no longer the only. Oops. No. Okay. We have to take the entire condition out because this is now a component of the entire condition. So now we have to go to operators. And I'll give you a hint. Okay, I'll give you the components, and then you guys tell me what logical operators I need to do that. I will use 2 of these things. I go to sensing. I'll put answer on the left-hand side of each one. Okay, and you can tell me what I should put here for answer to be invalid. Invalid. Okay, I guess I have to go kind of backtrack a little bit here. How do we compare letters? Numbers we know how to compare, but what about letters? Alphabetical letters. Yep.
We use lexicographical order.
That's exactly how it's done. So A is lexically less than B, B is less than C, and so on. That's exactly right. So knowing that, what is invalid for answer? Anything less than A is invalid, and anything that's greater than Z is also invalid. Okay? Now, if I want to specify all the invalid single letters or single things, what should I use to join these 2 together? I have and or to choose from. It's or, okay? Because this is one way for the whole thing to be invalid, and that's the other way for the whole thing to be invalid. Because, is that making any sense? If the input is less than A, or it is greater than Z, it is not within the range that I want. Okay? But since this is the negation of what I really want, I also need a not in order to say this is now what I want. Because the repeat until wants to know something that is what we want and not the opposite. Okay? All right, that's great. How do we join these 2 together?
Join. Use the join.
No, not the join. It's an and. And. Because we want the input to be a single thing, and we also want it to be between A and Z. Yep. When you think about this, you have to think about, do we want to make it more restrictive, or do we want to make it more general? That's basically the question. And makes it restrictive or makes it general. So we'll drag and drop this to here.
It's gone.
It's gone.
You can make that bigger.
Oh, you mean a different layout?
The one here
You mean here? That. Yep. Okay, but now I have to do with it again. That's okay. Length of answer is 1. Put this all the way to here. There we go. That's our condition. Any questions about the condition? It has 2 major components. One component to make sure the input has one thing, and then the second component make sure that one thing is a letter from A to Z. Anything else, it would make this entire expression false. So now it's time to drag this whole expression back to the hexagon of the until, like that. And it's time to test the program again. Okay? When you move on to cisp300, you should write programs, kind of not exactly like this, but I would definitely write programs, just in steps. So if the program stops working, okay, it has to be something that I did in the past 10 minutes. And chances are, you can probably still remember what you did in the past 10 minutes. So let's go ahead and run the program again. And this time we'll make the stage a little bit bigger so we can see what I just typed here. So try multiple words, multiple letters, didn't work, did not add anything to used letters. Try punctuations or digits. Okay, digit doesn't, it worked. Okay, that's not good. Okay, let's try punctuations. Punctuations did not work. Let's try, one works. So digits still work, but letters. Capital letters are actually compared to the same as lowercase letters. In other words, Scratch is case insensitive. So it's kind of a bad thing, but in this case it's okay. It's all right. Okay, so we have a bug here. Okay, what is a bug in software? A problem. Does a bug always have to cause the system to crash? And give you the blue screen of death? No. Okay. A bug is a defect. It's basically the program behaving not the way it's supposed to. That's all. Okay. So in this case, the program is definitely not behaving the way it's supposed to. So it's time to stop the program, look at the code here, and then try to figure out what is not working here. Okay. Should I just go in and just kind of randomly change certain things? No. Okay. Well, let's think about what if the answer is 0. Okay. If the answer is exactly 0, the length of answer will still be 1 because it's just one single digit, right? So that part is okay. 0 is less than the letter A. Do you think that's true? It's actually true. It is actually true because, you know what? One quick thing we can do is to do this. We can go here and just right-click on the block that we want to re-examine, duplicate it, put it outside here, and then we can, but answer is not a particular thing, so we'll take answer out, that, and then we just plug in 0 here. And then we can evaluate it. It says it's false, which is our problem. That is our problem. Don't you think? Because 0 is outside of the range of A to Z, and yet it is saying that 0 is less than A and 0 is greater than Z. It's false. It should have been true. Is that right? Because it's not inside A to Z, the range of A to Z. So this should have given me the answer of true. So I have pinpointed which part of the expression is the cause of the problem. Now the bigger question is, how do we fix it? The reason why it's having a problem like this is because it's comparing 0, the value 0, to the ASCII code of A. Okay. When we look at 0, there are two ways to interpret what we call 0. Okay? There's 0 as the value 0, which means there's nothing, none, zilch. Okay? But there's also the digit 0. The digit 0 has its own ASCII code. So the question is, what is it comparing here to give us the answer of false? Particularly, what we want to do is to look at this block here, because this expression should give us an answer of true, because the ASCII code of 0 is actually less than the ASCII code of A. but it's not telling me that is the case. It's telling me false. In other words, Scratch is having a problem comparing comparing values, numerical values, with letters. It's just, it doesn't know how to compare that. Any questions at this point? Yep.
No, it's not really a question, but maybe a suggestion. To kind of, avoid this. Well, in this instance, can you just say and not equal to or greater than 0? Just kind of validate the input. Would that be possible?
So instead of checking for anything that's outside of the range, check for things that are in the
I mean,
range.
you can still check because you need to, remove punctuation if that's useless input. But I mean, at least as far as for an integer or a number, can you do that in this instance? I'm not really familiar with Scratch, so I don't know. That's possible.
Well, if it's having problems with the comparison, there's no way to fix that. Couldn't you just make it even more restrictive and make it so that way the range of numbers is not a valid input? So that is the length of answer equals 1, and it's not less than A or greater than Z, and it is not.
I'm going to do something. Okay, let me try this here. The problem has to do with comparing a numerical value 0 with a letter which is A. So let me put it here like this one. I'm going to join 0 with nothing, like that, and then click it, and it says it's false, which is still not what it's supposed to be. I'm trying to force both sides to be the same thing, and it's not working. So there may not be any tool to make this work because it just doesn't have the ability to do the comparison. Okay, one last thing. Okay, I can give it a list of things, and then I will compare to each item, and this time I will be looking for the equality. Did you guys do the validation?
Yeah.
Did you check for 0? Okay.
If you go into a video game and you guess 0 as one of the letters, then you should get a thing wrong. I mean,
You should get another stroke, right?
Yes, because you're obviously guessing a wrong thing. So what's the problem there?
Well, the problem is I want to do it. The problem is I want to accomplish this, and the program is not letting me do it. Yep.
Wouldn't you, because the program is not letting you do it, wouldn't you just do another and statement and say, because it has to be 1 digit, all we have to make as invalid is the numbers 0 through 9. So 0 through 9 is also invalid, as well as the length of answer has to be 1 and it has to be less than A and greater than Z. You will remove the number from the possible answers. It won't work.
From negative 9 to 9? Or would
It has to be 1 digit.
Okay.
Negative, simple.
Okay, this is what I'll do. I remember linear search. I give you an array. I give you a number that I'm looking for, and you can tell me, an algorithm can tell me whether it's there or not. I'm going to use that approach now. Okay. So to test that approach, I will write another script here. I'll keep this one here, but I'll write a separate one. Okay. Control. This time when the space key is pressed, I will start this one. I will add to the variables, make a new variable, and I'll say valid characters. And the first thing I will do is to initialize valid characters, not to 0, but to all the letters. So this one is A, B, C, D, E, F, G, Q, R, S, T, Z. All right. So this time, my task, is changed from checking for things that are out of range to matching it to exactly one item within the array of things that is supposed to be acceptable. Okay, so I'm flipping the polarity of the check, and this time it's going to be a little bit easier. Okay, I will also have to use a new variable called valid. Okay, it's a Boolean variable. It just has to remember whether the number or the input is actually valid or not. So I would say valid is going to be 0 to begin with. 0 means false in this case because Scratch doesn't really have Booleans. It cannot remember. It might be able to remember true, false. How can I check whether it can remember true or false? I can check it, right? So what I can do here is I can set it to, okay, I can separate it first, go to operators, and just use one comparison, and say this is 1 on one side, okay, 2 is fine, okay. The other side is 0. I click this operation, and when we look at it on this side, you can see valid is false. In other words, the variables can actually store true, false values. Yep.
So how I actually did mine was for every single letter, there's code that allows you to input that letter. So all my other characters, you're not allowed to input them.
Okay.
So the code checks, when you enter it, it checks against the word to see if it's there.
So your user interface by itself limits what kind of letters can be used.
Yeah.
Okay. So it's not a free form input, therefore you don't even start with its problem.
Right.
Okay. Well, that's a very good point. It really goes a long way to explain how to design a user interface. Is one, don't let them make mistakes. Very good. And you can also hide a letter once it's used. You just make it hidden so it cannot be used again, and you don't have to check for that one more time. Okay, very good. Nice, very nice. But as far as this class is concerned, we still want to kind of do it this way, because we want to kind of revisit the algorithms that we have done and then translate it to this particular mechanism. All right, so we want to change valid to false. So let me see if I can just type false here, and it will take it as false. Yep, looks that way. All right. Do you guys still remember linear search? What else do we need in that algorithm?
Order. Order.
Well, you need I, right? You need something to control and say, okay, which letter in the array am I looking at? Do you guys remember the I? The variable controlling the index? Okay. So I need one more variable. So go to variables, make another one, call this one I. And it's only really useful for this sprite. The other ones are only useful for this sprite too. Okay. So I have to set that variable, set I to 0. I'll set it to 1 in this case. Why am I setting it to 1 instead of 0?
Scratch starts this one.
Yep, Scratch starts with 1. And why do you think Scratch starts with 1 instead of 0? Because it's easy, it's more intuitive. Scratch is not designed for computer science students. It's designed for people who are trying to get into computer science. And I think it is not, a nice feature to start with 1, because then programmers will have to, people who use Scratch have to switch mentally back to starting with 0 later on in their career. So you just have to remember this part here. We'll have a loop. Go to control, go get a loop here, which is repeat until. What should we put here? In other words, I'm trying to match the answer to the question to one of the letters in valid chars, okay, which is A to Z. So when can I get out of this loop? And this is also another, there's another test here to see whether it is using short-circuited evaluation. Do you guys remember short-circuit evaluation? Where if you can evaluate one side, if it is already giving you the answer of the entire expression, you do not evaluate the other side. So we don't know whether it is going to do it or not here in Scratch. When do I get out of this loop? Okay, 1, I have just found the letter, right? 2, I have searched through the entire array and I still cannot find the letter, right? Okay. So I need to go to operators, What did I just say? Did I say and or did I say or? Or. That's right. Two reasons to get out of the loop. Assuming it does have short-circuited evaluation, should I check for the range of I first, or should I check whether the current letter is matching the answer? The other way. I should check to make sure that I is within the right range first, because if I is out of range, I don't want to perform the second part. Right? Okay, so I want to check the validity of I first. I'm going to use the less than operator here to check for I. So go back to variables, make I one side. What should I use on the other side? I want I to be a valid index at this point before I get into the loop. If I is already out of range, I want to get out right away. Oh, okay, I should be, sorry, flip it. So I, when is I invalid? I is greater than what, and then it's invalid. Remember I starts with 1, yep.
The length of valid chart.
Exactly, just the length of it. Just the length of it. So you go to operators, you pick length of, and then you go back to variables, and then you pick valid chars. Okay. Very good. What about the other condition? What should I be checking for in the other expression? It's just the equality, right? Because I'm picking one letter out of valid chars and compare that to the answer. So I have to think in reverse because I have to think operators. So I have to check for equality first. And then I go to letter blah of blah. And then go to sensing, pick answer. Here. This letter thing, I have to go back to variable because I controls which letter I'm looking at. And I'm looking at that particular letter out of valid chars. Like that. You think this is longer or shorter than the pseudocode version of the same algorithm? It's way longer, right? Why do you think this is way longer? It's really expressing the same logic, except it's flip side, but why is it way longer? What about the notation? What notation do we need when we use an array? When we try to access an element inside an array, what notation do we use? No, not the bars, the square brackets. Okay, the square brackets will let us index to one item inside an array. Over here, it is letter blah of blah. Okay, so that's why it's taking up more space. What about the length of something? That's our bar notation. Two punctuations in our pseudocode notation, and now it's spelled out as length of da 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 da. And that's why this looks a lot more cumbersome and longer. If you give our pseudocode to someone who doesn't understand pseudocode, do you think that person can natively and inherently look at the code and go, oh, I understand the algorithm exactly? Probably not, because the notation is kind of cryptic. How about presenting this logic to somebody who doesn't understand programming at all? There's a good chance. There's a better chance. Okay. And what do I do inside this loop here? Same thing with the pseudocode. What do we do in the pseudocode in the loop when we are looking for a match? And let's just say that we are not smart this time. We don't really take into account that this is a sorted array. What do? We change I1. I gets I plus 1. Right? If the current letter is not what we are looking for, we bump up the index so that in the next iteration we'll be looking at the next character and so on until we get to the end of everything. Okay. After we get out of the loop, I have to set valid to either true or false. The question is, how should I change this 0 so that it tells me whether the letter is really there or not. Is the input valid? That's the question. What do you think? I need to set valid to, well, I know it's Boolean because valid is either true or false. It's either valid or invalid. But what should I put here? Okay, let's let's say that the letter is actually in the array. If the letter is in the array, the loop will exit because of which condition? Let me point to the two conditions here. If the letter does exist in the array, will I be exiting because I gets out of range? Or will I be exiting because letter I of valid chars equals to the answer? The second one, right? Okay. Which means the first one is going to be false because I'm not out of range yet. Is that right? So what I can do now is to flip the comparison of length of valid chars and use that as a indication whether I found it or not. I go to operators, go to not, and then just pick the comparison, duplicate it, and put it in here. Why do I need to use a not? Because when I is greater than the length of valid chars, it actually means the opposite. It means that the answer is out of range. It's not found in the array. So that's why in order to make this valid, I have to flip invalid into valid. Are there any questions? No? Okay. And we are done here. We'll go to, I think we can just end it here. And just remember to put ask at the very beginning. Input a letter and wait. Okay. All right, so let's go ahead and run this program, but this time I cannot use the green flag. I have to use a space bar to start the program because I only want the second program to start but not the first one. Okay, we'll try the obvious. Okay, we'll try a single letter and it says valid is true. We're good. Okay. We'll try again. This time I'll try a single digit. What do you think will happen this time? 6. Will 6 ever match A to Z? No. Okay, so it should come back and valid should be false, right? And valid is false. Very good. And here's the next question. What if I give it something also invalid, like what do you think will happen? It'll come back as false. Okay, the program will not break. It will not, do anything that is wrong. It will come back valid being false. Why do you think that's the case? Because it's now comparing the entire sentence to one single letter for each iteration, and that will never match. Okay, but just to be sure, we will try it out, and you can see that valid comes back as false too. Capital letters cannot be checked because it's case insensitive. So as far as Scratch is concerned, lowercase a equals uppercase a. So uppercase letters will match too, will come back as valid. We can double check that. We can just run the program again, give it an uppercase T, and it comes back as true. Okay. Great. Now we have one component done. And how should we integrate this into our code up there? Well, okay.
Remove the information in the forever and input that one.
Okay. Okay. So let me put these things away. If we just concentrate on this block here, do you think this block needs to be done only once for each letter input? Or do you think I might need to do this over and over again? As long as the user is inputting something that is invalid, I have to do it over and over again? I might have to do it over and over again, right? So there is one place I can put it, which is in here, right? So I'll take this one out. Come on, go away. Like that. Stick this entire block in, like that. And we have a problem here. No. Back in, get away. All right. Now we do have a problem here. What is the problem? I'm checking answer before asking the first time. Okay. And also this loop is not getting out, based on whether it's valid or not. So I know I have to do something about this. Let's get rid of this whole thing here. All our hard work gone. What should I put there instead? I can rearrange the code just a little bit and make it very easy to deal with. The whole thing has to do with whether the input is valid or not, right? If I can verify the input is valid, I'm good. I should exit the loop. But as long as valid is not, is not true, I should stay in the loop. Is that right? What about this? I set valid to false. Okay, this is a little bit cumbersome. I put set valid to false before that. And then I put the variable here, okay, until valid. Oh, it doesn't let me do it because it wants to see whether valid is true or not. So I will have to use the equal operator. Put valid on one side, put true on the other side. Like that. What do you think? I set valid to false to begin with before I check for anything. So that guarantees that I will have to go into the loop at least once. And the loop should be like that. Do you think it will work? Okay, let's double check. I'm assuming the input is invalid because I didn't have a chance to ask just yet. The loop will exit as soon as valid becomes true. But as long as valid is false, I asked the end user to input a letter and wait. And then we'll set valid chars to this. This only has to be initialized once. So we'll go ahead and separate this, put it all the way to the beginning because it only has to be done once. And then the rest I want to put back into here. This part, we can deal with it later. This is the loop here. Set I to 1 all the way down to out of the loop here. That's for checking whether the input is valid or not. Let's go ahead and run the program and see whether it works or not. How should I test a program like this?
Start with asterisk.
Actually, one code is actually out of place right now. I need to fix that first. It's joining the used letters. No.
Better save it.
No, just minimize and then maximize it. Oops. No. There we go. This has to be done outside of the inner loop, and then the rest go back into the inner loop. All right, so this is good. Okay, let's check. Input a 0. It's not added to used letters, which is good. I input lowercase a, and it's added to used letters. I input too many letters, and it's not added to the list. I add another letter, and it's added to the list. So far so good. All this logic just to make sure the input is between A to Z. But are you surprised? I mean, are you surprised about the complexity of the logic for validation? Well, most people say half the size of any program is just for checking for validity. And that's actually also where most of the bugs are, because a lot of times the person who's writing the program cannot think of ways that it can go wrong, that someone can input something that is invalid. When you think about it, does that make sense? So let's say you are the programmer, okay? You are the one who's writing the code, and you're trying to think, okay, let's think about a zip code, okay? So you're thinking about a zip code, and you're thinking, okay, how can things go wrong when people input an invalid zip code? But in your mind, because you are the one who already know what is considered a valid answer, so most of the time your mind is focused on the valid answer, and a lot of times we cannot think of ways for the answer to go wrong. Okay, what is invalid? And that's why programmers or the developers cannot be the same people who test programs. Is that making any sense? The people who test programs have to be people who are basically just have one job, which is to break programs. That's their job. All right. So we are good so far. Okay, next. Do you think it will be hard for us to remember what letters have been used? It's actually not as hard as we think. Okay, how would you do it? In order to only remember the letters that can still be guessed, that is still on the list of unused letters. See, one thing we can do, I don't think we have enough time today to get that part done. So instead of valid chars to be constantly A to Z, whenever we see a new letter, like A or B or C, we remove that letter from valid chars. So every time there's a valid input, we change valid chars so it becomes one letter short of the one that has just been guessed. So this way, when we validate, we also automatically validate to make sure it is a letter that has not been used before. Is that making any sense? Kind of? Okay. But we do have to change the structure of the program. The way it is right now is not going to work. And we may not have enough time today to do that. But just the part that we have at this point, how many people think, okay, I can probably get this, I understand how it works. Okay. What about the part of, okay, I give you Scratch, I tell you what it is supposed to do, and you write this code? It's probably okay for some people, but probably not so for some other people. So I think we are making, okay, let me ask another question. We still have 5 minutes. How many people think that they can relate this particular Scratch program to the pseudocode that we have been talking about in this class? So there's a match between the features here and the pseudocode. Okay, that part is important. All right, so I'll let you guys go 5 minutes early because I think we can finish this part later. I'll save it into today's folder, and if I remember to upload, you guys can have a copy of this too.
Just the last part you talked about, is there a code for this, or this won't make sense at all?
No, it doesn't have. It doesn't have any operator to do that.
Okay.
That would be nice, but it doesn't have that feature. So what we need to do is when we go through the list, when we go through valid chars, we have to create a second array as we go through it, and we skip over the letter that we are now guessing when we have a match. So if it's not matching, copy it down. If it does match, do not copy it. So that's the only way. That's one way to do it.
Think about it. Also, was some homework due today?
Yeah. You forgot? Oh man.
How many points?
It's about the same as all the other homework assignments.
there's no way to make up that point.
No, I'm sorry.
Alright, thank you.
Yeah, I have a question. May I have my test that you did? Because I didn't get it back.
I didn't bring my test today, so
Oh, really?
I'll bring it on Thursday.
Okay. Because you already gave the grades out, or you didn't?
The grades are already on in the system.
Oh, really?
So when you check Moodle, you should see your grade.
Under which name is it there?
Exam 1?
Exam 1?
Mm-hmm.
Okay. I was looking yesterday, it was not there though.
It wasn't there?
Yeah. It was like 3 homeworks that you gave, and that's it.
That's exactly
Yeah.
I tried to upload the homework assignment this morning, and it wouldn't let me upload it for some reason.
It will up. I think it's open until 10:30 a.m. today. When did you